Single-case design questions become difficult when we try to name a graph from its shape. Two graphs can both rise or fall while using completely different experimental arrangements. In this lesson, we will separate reversal, multiple baseline, multi-element, multiple probe, and changing criterion designs by asking how the independent variable is arranged and how control is replicated. We will build the concepts first and then work through 20 application questions. If you want another way to test the same reasoning, our free BCBA mock exam is available after the lesson. A single-case graph is evidence only when its phases were arranged to test a causal question. Before naming a design, identify what was deliberately changed, where replication can occur, and whether the comparison is feasible. A rapid comparison points toward multi-element logic. Staggered starts point toward multiple baseline. Quantitative goal shifts point toward changing criterion. Withdrawal and reintroduction point toward reversal. That order prevents us from treating the participant count or the direction of the graph as the design label. A reversal design tests whether behavior follows the intervention as it is introduced, removed, and introduced again. Imagine aggression falling when treatment begins, rising after treatment is withdrawn, and falling once more after reintroduction. The important evidence is not simply improvement during the first treatment phase. The withdrawal verifies the earlier prediction, and the return of the effect replicates it. This design is useful only when withdrawal is acceptable and the behavior can plausibly move back toward baseline. Read the 4 phases as a sequence of predictions and tests. A1 establishes what behavior looks like without the intervention. B1 introduces the independent variable and gives the first possible effect. In A2, withdrawal tests whether the earlier baseline pattern returns. That verifies the prediction made from A1. B2 then reintroduces the intervention and asks whether the effect returns. The strongest conclusion comes from behavior changing systematically with those repeated on and off changes, not from the letters A and B by themselves. Reversal is not automatically appropriate just because an intervention can be physically removed. 2 questions come first. Can withdrawal occur without unacceptable risk? And is the treatment effect likely to reverse? A learned reading skill may remain after teaching stops, so removing instruction would not recreate the original baseline. An intervention that prevents dangerous behavior may be unethical to withdraw. In either situation, a design that demonstrates replication without withdrawal is usually more informative. The strength of reversal logic is also its main constraint. When a response is reversible and withdrawal is safe, repeated phase changes can produce a direct demonstration of control. When learning is durable, carryover is strong, or withdrawal would expose the client to harm, the A2 phase cannot do the job the design requires. Design quality, therefore, includes ethical and behavioral fit. A powerful experimental arrangement can still be the wrong choice for the target and context. Multiple baseline replaces withdrawal with staggered replication across separate tiers. The tiers might be people, behaviors, or settings. Each tier begins in baseline, but the intervention starts at a different time. Experimental control becomes more convincing when the untreated tiers remain stable and each tier changes only after its own intervention begins. The stagger matters because it gives us repeated predictions. If the intervention is responsible, later tiers should not change early. Picture 3 classrooms using the same staff training package. All 3 begin with stable fidelity data. Training starts in Classroom 1, while Classrooms 2 and 3 remain untreated. Only the first classroom improves. Training then begins in Classroom 2, followed later by Classroom 3, and each improvement follows its own start. That sequence weakens a simple history explanation because the calendar date is not enough. The change repeatedly aligns with the intervention in each classroom. The tier is the unit across which the stagger is replicated. It can be a behavior, a participant, or a setting, but the tiers must be sufficiently independent. If training one staff member immediately changes the untreated staff, the later tiers no longer provide clean predictions. A multiple probe variation keeps the staggered logic while sampling some untreated baselines intermittently. That can reduce unnecessary measurement for skills likely to remain absent until teaching, provided the probes still support adequate prediction. A convincing multiple baseline needs more than different start dates. Baselines must be predictable enough to show what would likely have happened without treatment. Tiers must not change one another prematurely. The decision to start the next tier should follow data, not a fixed calendar alone, and the effect must repeat across the staggered starts. If several untreated tiers improve before their own start, the core inference is weakened even though the graph still looks staggered. A multi-element design answers a comparison question by alternating distinct conditions rapidly. Method X and method Y might appear in brief sessions, each with clear cues, so their effects can be compared without waiting for long phases. The key evidence is differentiated responding that reliably follows the current condition. A simple A to B phase change is not multi-element, and rapid alternation alone is not enough if the data never separate. The short timescale is both an advantage and a risk. Alternating X and Y can reveal differences quickly, but participants need to discriminate which condition is active. Balanced or otherwise well-planned sequencing helps prevent one order from dominating the comparison. We also need enough repeated exposure to see whether differentiation is reliable. One unusually high X session and one low Y session would not establish the same relation as a consistent, replicated separation. 3 threats deserve special attention. Carryover occurs when one condition continues to affect responding in the next condition. A sequence effect occurs when the order itself changes performance. Weak condition cues can prevent the participant from discriminating the contingencies. These problems make the present data harder to attribute to the present condition. Clear cues can support control, but they cannot repair a treatment effect that persists strongly across conditions. Multi-element designs fit best when effects appear quickly, conditions can remain distinct, and carryover is limited. They are weaker for slow skill acquisition or treatments whose effects accumulate across sessions. In those cases, rapid switching may compare a mixture of current and previous conditions rather than 2 separable effects. The research question may still be comparative, but another arrangement may be needed to preserve interpretability. A changing criterion design keeps the same target behavior and intervention while shifting the required quantitative level across phases. For example, the goal for independent work might move from 5 minutes to 10, then 15. Control is demonstrated when behavior repeatedly tracks those plan values. Merely changing the goal is not evidence. The dependent variable must covary with the timing and magnitude of the criterion shifts. The step pattern lets one behavior provide several replications. Performance stabilizes near 5, then moves near 10 after the criterion changes, and later approaches 15. A planned return to 10 can be especially useful because behavior must reverse direction with the criterion. That bidirectional shift is not an A-B withdrawal. The treatment remains in place. Only the quantitative performance requirement changes. Criterion steps should be large enough to detect a meaningful change, but still achievable from current performance. Each phase must last long enough to judge whether responding has stabilized. Moving the criterion every Friday, simply because the calendar changed, can obscure the functional relation. The phase change should follow the data. Direction can move upward, downward, or both, as long as the behavior has a reasonable opportunity to track each value. 4 features strengthen criterion control: a stable starting level, distinct but attainable steps, adequate data within each phase, and repeated matching shifts. If behavior rises before every new criterion, a general trend may be driving the data. If it remains near one level while the criterion moves, the intended design exists, but control has not been demonstrated. A bidirectional change can add a particularly persuasive replication when it is clinically appropriate. The 4 designs answer different causal questions. Reversal tests one intervention through safe withdrawal and reintroduction. Multiple baseline tests the same intervention through staggered starts across independent tiers. Multi-element rapidly compares distinct conditions. Changing-criterion tests whether one response tracks successive quantitative goals. The best label comes from that experimental arrangement and replication logic, not from a number of participants or whether the graph slopes upward or downward. When selecting a design, begin with a research question. Use multi-element logic for a rapid comparison of separable, quickly acting conditions. Use multiple baseline when withdrawal is undesirable and independent tiers can be staggered. Use changing criterion when the intervention is expected to move the same behavior through planned quantitative levels. Use reversal when one intervention can be safely withdrawn and the effect can plausibly reverse. More than one design may be possible, but one should answer the stated question most directly. A downward trend cannot identify a design. The same improvement could occur during an A-B sequence after staggered starts across rapidly alternating X and Y sessions, or while a criterion moves from 15 to 10 to 5. To identify the design, describe how the independent variable was arranged and where the effect was replicated. This is the final protection against choosing from graph shape alone. The design map is complete, so we can move into 20 practice questions. For each item, name how the independent variable is arranged and where replication would appear. Then check feasibility, reversal, tier independence, carryover, or attainable criterion steps. A graph trend or participant count may be present, but neither identifies the design by itself. Choose one option before the explanation compares all four against the experimental logic in the stem. Question 1. A BCBA raises an independent work criterion from 5 to 10, 15, and 20 minutes. Performance changes in step with each criterion, and treatment is never withdrawn. Which design is used? A. Reversal design. B. Multiple baseline design. C. Multi-element design. D. Changing criterion design. Track how the independent variable is arranged and where the demonstration of control could occur. Pause briefly and decide which option accounts for every detail. The correct answer is D. Changing criterion design. Successive quantitative criteria produce matching stepwise changes. Control is shown when behavior tracks each planned criterion shift. That is why the arrangement changes one quantitative goal in planned steps. Now, compare the first alternative. Reversal design. No withdrawal and reintroduction occur. Next, consider another possibility. Multiple baseline design. No intervention is staggered across tiers. Finally, look at the remaining option. Multi-element design. Conditions are not rapidly alternated. Moving criterion plus matching behavior means changing criterion. Question 2. 3 classrooms begin with stable fidelity data. Staff training starts in classroom 1, then 2, then 3. Fidelity improves only after training begins in each classroom. Which design best demonstrates control? A. Reversal design. B. Multiple baseline design. C. Multi-element design. D. Changing criterion design. Classify the design from the sequence of conditions, not from the surface topic of the intervention. Take a moment to choose and be ready to name the evidence that decides it. Choose B. Multiple baseline design. Change follows 3 staggered intervention starts. Each tier changes only after its own intervention start. The principle underneath that decision is this. Replication across independent tiers supports a multiple baseline demonstration. Begin with the first contrast. Reversal design. The intervention is never withdrawn. The second contrast raises a different issue. Multi-element design. Conditions are not alternated within tiers. Complete the comparison with the last alternative. Changing criterion design. No stepwise quantitative criterion is programmed. Staggered starts across tiers point to multiple baseline. Question 3. A learner receives method X and method Y in brief, alternating sessions with clear condition cues. Correct responding is consistently higher during method Y. Which design is most directly represented? A. Changing criterion design. B. Reversal design. C. Multi-element design. D. multiple baseline design. Look for what changes across phases or tiers and what stays available for comparison. Make your selection before the explanation appears. C. Multi-element design is the best answer. Start with the decisive detail. Two conditions alternate rapidly and yield differentiated responding. From there, rapid comparison of conditions is the defining multi-element arrangement. The design compares effects without waiting for long phases. Set the evidence beside the first alternative. Changing-criterion design. No successive goal values are used. Then check the next one. Reversal design. The independent variable is not systematically withdrawn and reintroduced across A and B phases. Two conditions are rapidly alternated instead. There is one last option to examine. Multiple baseline design. Treatment is not staggered across separate tiers. Rapid alternation plus differentiation means multi-element. Question 4. Aggression is stable in baseline, decreases when an intervention is introduced, rises when the intervention is withdrawn, and decreases again when it is reintroduced. Which design is this? A. Reversal design. B. Changing-criterion design. C. Multiple baseline design. D. Multi-element design. Use the timing of each condition change to decide which experimental logic the stem describes. Stop here long enough to test each choice against the stem. The stem supports A. Reversal design. The repeated phase change is the core logic of a reversal design. The stem supplies exactly that relation. Behavior reverses with withdrawal and replicates with reintroduction. The same independent variable is deliberately turn off and back on. First, read the opening alternative against the stem. Changing-criterion design. No quantitative criterion is shifted. From there, assess the next choice. Multiple baseline design. No staggered tiers are present. Finish by testing the final choice. Multi-element design. Conditions are not rapidly alternated. On to off to on with matching behavior means reversal. Question 5. In a multiple baseline across behavior study, all three behaviors improve before the intervention is introduced to the second and third tiers. What is the main design concern? A. The criterion changes too slowly. B. The staggered replication is weakened. C. Carryover between alternating conditions is too high. D. The behavior is not reversible. Separate the visual pattern in the data from the design arrangement that produced it. Choose one answer now. The next page will compare all four. Our answer is B. The staggered replication is weakened. What the answer must explain is that untreated tiers change before their scheduled intervention starts. Premature change across tiers weakens experimental control. This follows because the design loses evidence that change is tied to each staggered introduction. One alternative takes a different route. The criterion changes too slowly. Changing criterion logic is not being used. Another route changes the relation. Carryover between alternating conditions is too high. No rapid alternation is described. The remaining route deserves the same check. The behavior is not reversible. Reversibility is not the central multiple baseline test. Untreated tiers should remain stable until their own start. Question 6. A clinician changes a walking criterion from 500 to 700 to 900 steps, but performance remains near 600 steps across all phases. Which conclusion is most accurate? A. The data show a reversal effect. B. The data demonstrate multiple baseline control. C. The changing criterion relation is not demonstrated. D. The data show a multi-element comparison. Notice whether the same effect is tested again within a case, across tiers, or across conditions. Commit to an answer before we reveal the reasoning. The best supported choice is C. The changing criterion relation is not demonstrated. The key evidence is not a label, but a relation. Behavior does not track the programmed criterion shifts. Changing criteria alone do not establish control. Responding must covary with them. As a result, the intended design is present, but its functional relation is not shown. Check the fit of the first alternative. The data show a reversal effect. No withdrawal phases occur. Move on to the next choice. The data demonstrate multiple baseline control. No tiers receive staggered starts. Close the set with the last one. The data show a multi-element comparison. No rapidly alternating conditions are compared. Design label and demonstrated control are different judgments. Question 7. A BCBA evaluates the same reading intervention across 3 learners with stable baselines. Fluent decoding is expected to persist after instruction stops, so behavior is unlikely to return to baseline during withdrawal. The intervention can be introduced at different times across learners. Which design is the best fit? A. Reversal design. B. Multiple baseline design. C. Multi-element design. D. Changing-criterion design. Check whether withdrawal is possible before treating a return to baseline as part of the design. Give yourself a short pause and identify the decisive relation. This is B. Multiple baseline design. The intervention is withdrawn in reversal logic. The acquired skill is expected to persist, making reversal uninformative here. The deciding support comes from the stem. 3 independent learner tiers permit staggered intervention starts without requiring behavior to return to baseline. Multiple baseline can demonstrate control through replicated changes synchronized with each learner's intervention start. Against the same facts, consider the first alternative. Reversal design. Withdrawal is unlikely to reproduce baseline performance because the learned skill is durable. The evidence also bears on the next choice. Multi-element design. Rapid alternation would answer a comparative question not posed by the stem. One more comparison remains. Changing-criterion design. No planned sequence of quantitative performance criteria is described. Durable learning plus independent tiers plus staggered starts means multiple baseline. Question 8. 2 interventions alternate each session, but the effect of one continues into the next condition. What most directly threatens interpretation of this multi-element comparison? A. Carry over multiple treatment interference between conditions. B. Failure to stagger intervention across tiers. C. Lack of a quantitative criterion. D. Failure to withdraw treatment for a full phase. Decide which comparison is actually programmed rather than inferred from the number of participants. Select the best answer, not simply the first true statement. Answer A, carry over, multiple treatment interference between conditions fits the full relation. Read the evidence and rule together. The effect of one condition persists into the next condition. Carryover creates multiple treatment interference and weakens attribution of current responding to the current condition. That combination supports the selected option. Take the first option on its own terms. Failure to stagger intervention across tiers. Staggered tiers define multiple baseline. Now, turn toward the second alternative. Lack of a quantitative criterion. Quantitative criteria define changing criterion. At the end, examine the remaining choice. Failure to withdraw treatment for a full phase. Full withdrawal phases define reversal, not multi-element. In multi-element designs, ask whether one condition contaminates the next. Question 9. A behavior tracks criteria of 10, 15, 20, then 15 responses per session. The downward shift also produces a matching decrease. What does the bidirectional change add? A. Evidence of rapid alternation. B. A stronger replication of criterion control. C. Proof that no confound is possible. D. Evidence of staggered tiers. Ask what event would count as replication in the arrangement described here. Hold your choice and check whether it explains the complete scenario. The correct answer is B, a stronger replication of criterion control. Behavior follows an upward and later downward criterion shift. Once that fact is established, the reversal in criterion direction strengthens the changing criterion demonstration. Bidirectional tracking provides an additional replication of the programmed relation. Start the option check here. Evidence of rapid alternation. Conditions are not rapidly alternated. Continue the check with another possibility. Proof that no confound is possible. No design can prove that all confounds are impossible. End the check with the last possibility. Evidence of staggered tiers. No separate tiers are staggered. A planned change in direction can strengthen criterion evidence. Question 10. Behavior decreases from baseline to the first treatment phase in an intended A-B study. Before withdrawal occurs, what could be concluded? A. The first treatment effect is promising, but reversal control is not yet replicated. B. The full reversal relation is demonstrated. C. A multiple baseline relation is demonstrated. D. A changing criterion relation is demonstrated. Keep the intervention sequence, the unit of analysis, and the feasibility limits separate. Pause the video if you need more time to work through the options. Choose A. The first treatment effect is promising, but reversal control is not yet replicated. The item turns on one concrete feature. Only baseline and the first intervention phase have occurred. The data are encouraging without yet completing reversal logic. In functional terms, an A-B contrast suggests an effect, but verification and replication require later phases. The first nearby alternative needs a boundary check. The full reversal relation is demonstrated. Withdrawal and reintroduction evidence is missing. A second alternative depends on another distinction. A multiple baseline relation is demonstrated. There are no staggered tiers. The last alternative completes the set. A changing criterion relation is demonstrated. There are no successive criteria. An A-B change is not the same as completed A-B control. Question 11. A clinician evaluates a chained vocational skill across 3 learners. Before intervention reaches a learner, baseline probes are collected intermittently rather than every session. Teaching is introduced in a staggered sequence. Which design variation is this? A multi-element design. B. Changing criterion design. C. Reversal design. D. Multiple probe design. Identify the planned relation between baseline and intervention before interpreting the data pattern. Choose now, then compare your evidence with the explanation. D. Multiple probe design is the best answer. Multiple probe retains staggered replication while reducing continuous baseline measurement. Here, the confirming detail is that untreated tiers receive intermittent probes and staggered intervention starts. The intermittent baseline sampling distinguishes it from a standard concurrent multiple baseline. Put the first choice next to the deciding fact. Multi-element design. Conditions are not rapidly alternated. Now place the next choice beside that fact. Changing criterion design. No quantitative criterion shifts are programmed. Finally, test the last choice against the full relation. Reversal design. Treatment is not withdrawn and reintroduced. Intermittent baseline probes plus staggered starts means multiple probe. Question 12. A reading intervention produces fluent decoding that is expected to persist after instruction stops. Why would an A-B reversal generally be a weak design choice? A. The intervention cannot be introduced more than once. B. The design requires several participants. C. The behavior is unlikely to reverse to baseline when treatment is withdrawn. D. The outcome must be measured with intervals. Determine whether the design depends on reversal, staggered introduction, rapid alternation, or criterion shifts. Take a quiet moment to test the 4 conditions against the stem. The stem supports C. The behavior is unlikely to reverse to baseline when treatment is withdrawn. Begin with what the stem actually shows. The acquired skill is durable rather than readily reversible. Persistent learning can prevent the withdrawal phase from recreating baseline. The broader rule is this. Reversal logic depends on behavior changing when the independent variable is removed and returned. Read the stem alongside the first alternative. The intervention cannot be introduced more than once. Reintroduction is part of A-B logic. Use the same criterion on the next one. The design requires several participants. A reversal can be conducted with one participant. Apply that criterion once more to the final option. The outcome must be measured with intervals. Measurement system does not define the design. Reversal requires a reversible relation, not merely removable materials. Question 13. 2 reinforcement arrangements alternate rapidly with clear condition cues, but responding overlaps across conditions throughout the comparison. What is the best conclusion? A. A reversal relation has been demonstrated. B. The multi-element arrangement is present, but differential effects are not demonstrated. C. The conditions are functionally equivalent in every possible context. D. The design automatically becomes multiple baseline. Use the stated schedule of condition changes to rule out labels that only sound familiar. Decide which choice is fully supported before moving on. Our answer is B. The multi-element arrangement is present, but differential effects are not demonstrated. The conditions alternate, but the data do not differentiate. That observation narrows the field immediately. A design can be implemented without producing evidence of a differential effect. Overlapping data limit the conclusion to this comparison. They do not prove universal equivalence. For the first contrast, take the opening choice. A reversal relation has been demonstrated. The same independent variable is not systematically withdrawn and reintroduced across reversal phases. For the next contrast, use the second alternative. The conditions are functionally equivalent in every possible context. The conclusion cannot extend to every context. For the final contrast, examine the remaining choice. The design automatically becomes multiple baseline. No staggered tiers are present. Separate the arrangement used from the functional relation demonstrated. Question 14. After a baseline near 5 responses, the criterion immediately changes to 40 and remains there for the rest of the study. Behavior gradually rises to 18. What is the main limitation for changing criterion logic? A. The treatment was withdrawn too many times. B. Conditions alternated too rapidly. C. Too many independent tiers changed. D. There are not multiple planned criterion shifts for behavior to track. Check whether the stem provides repeated demonstrations of effect or only a single comparison. Make one selection and identify what would make the alternatives true. The best supported choice is D. There are not multiple planned criterion shifts for behavior to track. The choice succeeds because it accounts for this fact. Only one large criterion change occurs. Changing criterion control requires replicated covariation across successive quantitative values. A single jump followed by improvement does not provide stepwise replication. Compare the first alternative with the stem. The treatment was withdrawn too many times. No withdrawal is described. Now compare the next choice with the same evidence. Conditions alternated too rapidly. No rapid alternation is described. Use the stem once more on the final alternative. Too many independent tiers changed. No multiple tiers are described. One criterion change is not a replicated changing criterion demonstration. Question 15. Training begins with one staff member, but that staff member coaches colleagues whose untreated fidelity scores improve before their scheduled starts. What most directly threatens the multiple baseline inference? A. The criterion is decreasing. B. The intervention effect is too reversible. C. Cross-tier generalization compromises tier independence. D. The conditions are counterbalanced. Focus on the experimental arrangement first, then test whether the proposed design is practical and ethical. Pause here and follow the sequence once more before answering. This is C. Cross-tier generalization compromises tier independence. Coaching can make premature change, an intervention, spillover rather than a separate replication. The decisive evidence is this. Untreated tiers receive indirect intervention exposure. Multiple baseline depends on tiers remaining sufficiently independent until their own intervention starts. Bring in the first alternative for comparison. The criterion is decreasing. No changing criterion is used. Add the next choice to the comparison. The intervention effect is too reversible. Reversibility is not the central concern. Complete the set with the final option. The conditions are counterbalanced. Counterbalancing is associated with alternating comparisons. Ask whether one tier can change another before its scheduled start. Question 16. A BCBA wants to compare two brief prompting packages. Their effects occur within a session. Clear condition cues are available, and carryover is expected to be minimal. Which design is the strongest fit? A. Changing criterion design. B. Multiple baseline design. C. Reversal design. D. Multi-element design. Distinguish a design feature from a result feature, such as level, trend, variability, or overlap. Pick the option that explains the data producing relation. Answer D. Multi-element design fits the full relation. Two pieces locked together here. The goal is a rapid comparison of distinct, quickly acting conditions. Multi-element designs are efficient when conditions can alternate and remain discriminable. Together, they mean the scenario supplies the key protections against sequence and carryover problems. Look closely at the first remaining choice. Changing-criterion design. No stepwise performance criterion is planned. Shift attention to another alternative. Multiple baseline design. No staggered intervention across tiers is needed. Give the final choice one last comparison. Reversal design. A reversal design tests an intervention through withdrawal and reintroduction across phases. The STEM asks for rapid comparison of two packages. Fast comparison plus distinct cues plus low carryover means multi-element. Question 17. Behavior decreases in B1, remains low during A2, and remains low again in B2. Which feature most limits a reversal conclusion? A. The treatment effect replicated perfectly. B. The criterion changed in both directions. C. Behavior did not reverse when the intervention was withdrawn. D. Untreated tiers changed too early. Ask which rival explanation the arrangement is intended to weaken and how it does so. Commit to the strongest answer and hold onto the deciding fact. The correct answer is C. Behavior did not reverse when the intervention was withdrawn. Without reversal during withdrawal, the later B phase cannot replicate an on-off-on relation. The STEM makes that rule relevant by showing that the A2 phase fails to reproduce the prior baseline pattern. The persistent low level may reflect durable learning, carryover, or another variable. Test the evidence against the first option. The treatment effect replicated perfectly. The key replication pattern is absent. Repeat that test with the next alternative. The criterion changed in both directions. No changing criterion is described. Run the final test on the remaining choice. Untreated tiers changed too early. No multiple baseline tiers are described. If A2 does not move back, ABAB evidence is incomplete. Question 18. In a changing criterion study, responding rises several sessions before each programmed criterion increase. What is the primary concern? A. The design contains too many tiers. B. The independent variable is withdrawn too often. C. The conditions are insufficiently randomized. D. Behavior is not temporally tracking the criterion shifts. Look for the point at which prediction, verification, or replication is built into the sequence. Use a brief pause to separate the arrangement from the result. Choose D. Behavior is not temporally tracking the criterion shifts. Focus on the exact evidence rather than the topic name. The behavior changes before the supposed controlling event. Anticipatory or unrelated trends weaken attribution to the criteria. The rule that supports it is this. Criterion control requires behavior change to covary with the timing and value of each program shift. Another label in the set deserves attention. The design contains too many tiers. Tier count is not the issue. The next label uses a separate relation. The independent variable is withdrawn too often. Withdrawal is not part of the arrangement. The remaining label is the last comparison. The conditions are insufficiently randomized. Randomized alternation is not required for this design. The data should follow the criterion, not lead it consistently. Question 19. The same safety protocol begins at home, then school, then clinic. Performance changes only after the protocol starts in each location. What serves as the tiers? A. 3 settings. B. 3 treatment conditions. C. 3 quantitative criteria. D. 3 reversal phases. Choose the label that accounts for every programmed condition change, not just the most visible one. Choose the response that requires the fewest unstated assumptions. A. 3 settings is the best answer. The intervention is staggered across home, school, and clinic. This is the feature the correct option has to preserve. Settings can serve as separate tiers in a multiple baseline design. The replicated change follows each setting's intervention start. Hold the key fact next to the first choice. 3 treatment conditions. Conditions are not alternated rapidly. Now hold it next to another option. 3 quantitative criteria. The criterion value does not shift stepwise. One last time, compare it with the remaining alternative. 3 reversal phases. No treatment withdrawal occurs. People, behaviors, and settings can all function as multiple baseline tiers. Question 20. 2 studies both show a gradual downward trend. Study 1 alternates 2 conditions every session. Study 2 lowers a programmed criterion in steps. Why can the studies have different design labels? A design labels come from the experimental arrangement, not the visual trend alone. B. Any downward trend is a reversal. C. Only the dependent variable determines the design. D. Both must be multiple baseline. Before answering, name the arrangement, the replication path, and any limit the STEM explicitly establishes. Settle on one answer before we examine the contrasts. The STEM supports A. Design labels come from the experimental arrangement, not the visual trend alone. The final decision comes from the full relation. The same outcome shape is produced by different manipulations. Multi-element and changing-criterion designs are defined by how the independent variable is arranged and control is tested. In this scenario, graph direction alone cannot identify the design. The alternatives begin with the first choice. Any downward trend is a reversal. Reversal requires withdrawal and reintroduction. They continue with the next option. Only the dependent variable determines the design. The dependent variable does not define the arrangement. They end with the final alternative. Both must be multiple baseline. No staggered tiers are described. Name the manipulation and replication logic before reading the trend. Before we finish, compress the lesson into 4 decisions. First, ABAB, withdrawal and reintroduction. Second, stagger. Change follows each tier's start. Third, alternate, differentiated responding across conditions. Finally, criteria, behavior tracks plan goal shifts. These are not isolated memory lines. They're the sequence we can use when a new scenario changes the surface details. Keep the momentum going with our 2 free study resources. Use the free BCBA mock exam to test whether today's distinctions transfer to a longer set of questions. Then use the free quick study guide to revisit any concept that still feels close to a distractor. Both complete links are written on screen, so you can open the resource you need without trying to copy an address from the narration. Thanks for studying with us, and we will see you in the next BCBA exam lesson.